Hello all and welcome back. So in this video, let us now continue our discussion on hash maps, and now let's try to implement our hash map from scratch. First, we will be doing open addressing and then we will move to the closed hashing or the chaining approach. Okay. So now let us start with open addressing. To do open addressing, we will be maintaining two lists or arrays internally. So the first one is going to be keys, and the second one will in a way be a copy of this, but there we will be storing the values. Okay, so let me write down the names. Keys, it is also known as slots, and values. So the idea is that in the keys list, I will be storing the keys which you will be giving me and the corresponding value at the same position. So they will be equally divided with the same size, right? Along with that, I will ask my user for the capacity. So initial capacity which my user wants to give, and let's say we will also assume just maintain a size that how many have been added. Okay, great. So let us start then, everyone. We are going to create a class hash maps. In this class, I'm going to create a constructor. Now the things which I want in my constructor, they are just the capacity, right? So how long we want it initially to be. If we remember, like it was 8, I guess, in our dictionary by default, the one we saw on Stack Overflow. Maybe for the recent version of Python, if something has changed, we might have to see that. But yeah, it also takes up the capacity as 8 initially. Great. Now, first thing, self dot keys. So I'm going to make this because it's a constant size. So something like this, right, everyone? Capacity. Let us first define the capacity. Capacity is equals to capacity. So what we are getting here, that's the initial capacity, everyone. Now similarly, self dot values is equals to none. So to make it like an array, right? That is how we used to do it. None and capacity. Then the last one is self dot size equals 0. Great. So we have now made our overall structure where we have these things. Now let us first write the insert. Okay. So insert is also known as put. There here we will be getting two things, right? So self will of course be there. We will be getting a key and we will be getting a value. To not we can actually keep this slots, or let us just continue with keys only. Okay. Let us make it slots actually so that we don't get confused in this key and this keys. Okay, great. So I think I've added slash slots. Yeah, great. So just the reason is that to avoid any confusion. Great. Now, once you get the key and the value to add, okay, so for example, let's say I am sending that, hey, store apple with the value of say 10. So this becomes your key, this becomes your value. Great. Now what we can do here, everyone, let us see that. What exactly can we do? Once we get this particular thing, right, and let me make it values. So yeah, once we get the keys and the values, the very first thing which we have to do is to calculate the hash value, right? So that is something which we need, the index where we will be storing these things. Now to do that, either we can write our own function the way we discussed. We can take a prime number and have its power. Just one thing is there for words or for let's say tuple or anything. Tomorrow that can be a problem, right? For tuple, I will have to write another logic. If it is a string, then other logic. If it is a integer, then another logic. If it's a float, then another logic. We can define them, that is not a problem, but lots of logic we will have to handle. For the same, we actually have a hash function in Python. Okay, so if let's say we give it 1, 2, 3, and if I print, it's going to give me a value, which is going to be an integer. Let us run this. See, it is giving 1, 2, 3. So for integer, it returns back the integer. If I give it 1.23, it's going to give me a very big but an integer value. I can even give it ABC It's going to give me some value. There is one problem that it's negative. For that, what I can do, I can take it absolute. And now I'm sure that it will be positive as well. Right, everyone? So it's going to give me a hash value when I run it. It's converting the same into integer. Great. So that's the thing. The next thing, if you are asking for hash value of a list, you will see a very common or known error. Not an absolute, my bad, hash. See the error. Unhashable type list. We used to get this error when, let's say I'm making a dictionary, D 123 equals 1. So when I try to make a dictionary with key as a list, I used to get the same error. See, unhashable type list. Okay. So we are going to use this hash function, everyone. So let us use this to get the hash value. Okay. We are going to call hash function. Okay. Here we have to make sure to pass the key, because just through key we can get our overall hash value. So let me define another function, hash function. What it's going to do, everyone? So it's going to just calculate the value via the hash internal hash function. Okay, so I will be getting self and key. Here I just have to return absolute of hash of whatever key you are passing me. Okay, great. Once you have the hash value, and I'm assuming that we will also compress it here only. So to compress it, we will use capacity, right? So we have used capacity and we have the hash value. We can also write it as initial index. So if you want, just for overall better readability, it can also be set as a initial index, which we choose. Okay, great. Now let us see what happens when we have to insert something in a open addressing technique. So initially we have this empty array where everything is null for the keys as well as for the values. Okay, so just a second, let me make it a little bit space and let us write insert functionalities. Let's say if I'm asking you to insert apple here, first we converted it into a hash, then we compressed it and we got a hash value or the index, right? Hash value or the index. Let's say this index is somewhere at this position. So this index overall, which we have to add, it is coming out at this position. Okay. What we will have to do then? If it is none, then we can directly just add this particular thing to this key and this value. So what I'm saying is if, okay, self dot slots, right, hash value, if it is equal to is none, then though I think my work is done, right? If it is none, then I can directly just insert it here. So self dot slots hash value equals key, self dot values hash values equal value. Okay, so what effectively I've done, everyone? I said that, hey, this seems to be free. What you can do is save apple here and here save, let's say 10. If I enter 10 along with that, the problem happens. Let's say now I try to add orange, okay, with the 20. Here as well, I get the index, which again is pointing to this particular position. Then is where I have to make sure that I do linear probing, right? Or any open addressing technique. In this implementation, we can just do the linear probing. Then I will have to make sure to find a place for this orange. It might happen that some places are, some things are already kept here. Okay, so maybe let's say banana is already kept here. Okay, then we have to see that, okay, where can we insert orange? The whole idea of open addressing is I have to make sure to make the space for my overall element or the key and the value to be added. So else if self dot slots. Okay, so there is one more case, everyone, just to first discuss on that as well, which we have to make sure. When let's say you send not as orange, but you send apple here only. You said here only apple. Then what you will do? Then we have to make sure that we will go to this position only, but this time we have to update, not insert, right? So in your dictionary as well, if we used to write for a element which is already present, it didn't used to insert it again. We didn't used to say that, hey, this will become apple now. No, we used to make sure that we are updating the value. Okay, so pay attention. If self dot slots hash value, if it is equals to key, if the position which I have got, the index which I have got, if it is equal to key, then what do I do, everyone? Self dot values at this particular hash value will be equal to value. So I've updated it. Okay, let me write it down as well here. Update if key already present. Great. If this is not the case, then I have to make sure that I get the new hash value, right? So new hash value, or we can say it as new index position. For this, I will have to make sure that I do open addressing, right? So open addressing, or we just normally say that as rehash. Okay, so rehash. This is the function which is known as I'm passing hash value here. So let us create this rehash function then, everyone. What it's going to be? Def rehash. Okay, I will be getting a self, and along with that, I will be getting the old hash, whatever was the old hash value. What we have to return here, because we are doing linear probing, old hash value plus 1, and the same will be percentage of self dot capacity. Okay, I think we have made a error in the capacity spelling, and we have copied it out all along. Let me try if it can be corrected from here. Yeah, refactor. 1 minute. So we have to refactor it. Okay, 1 minute. Let us just see how it happens in VS Code. Capacity. Okay, I don't see it getting checked, so no worries. Let me just quickly copy it so that we are sure we are not making this problem. Okay, great. So yeah, I think now it's fine. We will be getting the new value, everyone, from this rehash overall. Let me write here as well. Linear probing done to avoid collision. Okay, straightforward. Great. Let us move forward. Once we have gotten this particular thing, once we have get the new value, then what we will do? Then we have to make sure. So let's say this time I'm passing orange and 30, and we are saying that the index again is this only. Index again is this. Great. So if this is the index again, I will have to do the linear probing and move forward. So till I'm able to find none. Okay, when will we stop? When let's say I find a none here, right? So great, let us see that particular thing. So I have to make sure that I keep on moving forward till I find none, right? So while self dot slots new hash value is not equal none, right? Or I can write it as is not none. What I have to do? I have to just keep on calculating this value, right, everyone? So we will keep on calculating this value. Great. Let's say I found my value here. So we are able to find our value here only. Or let's say banana was kept here with 40. Okay. And I found that orange I can just include here. Okay. So orange I include 30. Great. Now let's think, have we missed out on any case? I think we have missed out on one case. The case is that if let's say you send orange with 100 this time, what's going to happen? You will go here. Okay, let me draw it with the laser pen. You are going to go here again because orange will have the same overall hash value. You will see that, okay, this is not none. Let me move forward. Let me move forward. And let me move forward. You will find none here. And you are going to include orange again. Whereas what you should have done, see, while you were inserting, it can happen, right, that you didn't find it at the position, the initial position. So you did by adding it, just like we did here. But again, if the person wants to update the value, then we have to make sure that we stop either when we find none or when we are able to find our key. So key was orange in the initial. So we have to make sure of both these things, right, everyone? So what does that mean? I should stop just here, or, oh, sorry, and self dot slots new hash value is not equal to my key. So what does it mean? That, hey, keep on going until this is not none and this is not equal to key. Okay, so we have to make sure that we continue probing until an empty slot is found or key is found. Okay, so that's the case. Now again, if it's an empty slot, if self dot slots new hash value, if it is none, then what I have to do? I have to do the same thing. Just make sure that I add both the keys and the values, right? So that's what we have to do, everyone. Let me just add it. Yeah, great. But if that is not the case, then we must have said that, hey, key already exists. And if key already exists, then what we have to do? We will be self dot values new hash value equals value. Okay, great. So yeah, I think this is done. Let me zoom out. Yeah, see, these are all the cases I think which we might have to handle, everyone, where we have inserted our overall key and the value in my hash map which I have created. Okay, great. Let us move forward and let us now write the get part as well. Okay, so what I'm writing next? I am writing next get. In get, what can we do? Self key. Okay, so before moving forward, let me just first explain you properly that what exactly is going to happen. We will be having two overall these kind of list or array, right? What we will be doing here is that first I will check if you're trying to add if I have space here or not. Okay, if the space is there, if the space is there, then I will go and just directly add. Let's say apple 10. Great. If the space is not there, then I need to do linear probing. In linear probing, I just keep on moving forward. Right, everyone? Say I have to now next add orange. Okay. So orange is also saying that, hey, I want to come here. If the overall index, there is no collision, then it's fine. You will just insert it. Orange, you will insert here. Okay, with let's say 20. Similarly, banana can be inserted here with 30. Great. So till now, I don't guess any problem should be there. Now the next thing is that now let's say if I give you banana again. Okay. We will keep on going. So what we will do is we will keep on going forward. Either we see banana because that would mean that when we first added banana, we did linear probing and we were able to just get it here. Or we will get a none. Because in linear probing, the thing is that if you get none, okay, it is for sure that it will not be after that. Because we would have done linear probing, right? So we would have just got by a single step while going forward. So these are all the cases, everyone, which we have to handle. One thing more. So let me just help you visualize this as well. It's a very good tool which I found. So 1 minute. Let me just copy and explain you via this as well. It's going to be awesome. So pay attention, everyone. I will share this tool, the link overall. Okay. This is 1 minute. Yeah. So this is the overall closed hashing here we have taken a hash map of 29 size. Okay. So first let us introduce 30 and see where it go. 30, it will go on 1. Why? Because 30 percentage 29, it's 1. Right? Great. Now let us see one more thing. What is 59 percentage 29? It's 2. 59. It's 1, right? So let me now add 59 and see insert. See what's going to happen. It's 1. It will go here, but it will move by one step, right? Now 59 plus 29, 88. Let us do 88. See insert. It is 1. It's going to go here, then go here, then finally insert it here. So you see how linear probing is happening, everyone. I will just share this tool. It's an awesome tool for visualizing everything. Now let's say if I add normally 100, I don't know what it is, 13. So it will directly get added. Now let's say what I'm doing now, let me try doing 88 again. I think it is not asking me for the value, but it will say that it is already present. See, this time it will not add 88 again. It will stop here. Okay, no, it is, yeah. Okay, so here it is just having the case where it is supporting this thing. Let me have with strings, maybe something. ABC, hashing ABC. So it is doing some complex hashing technique, right? And it is able to, okay, so lots of logic it is applying, no worries. Okay, so finally it is getting something done. Let us increase the speed. Some very complex logic it is applying, seems like. So once it gets the value by 29, and it is adding it here. Okay, so that's the way it is handling everything. So if I insert by 30, okay, it is doing the hash string, it is doing that hashing by some different logic here. Great. So here it is allowing duplicate, but in our case, we don't have to allow the duplicates, right? So it is getting added here. We saw for 59 as well. It's going to get added here. And again, if I just change it to quadratic probing, then see everyone what's going to happen. 30. See, it's added here. 59. It will be 1 as well. So it will increase and get it here. 88. Here. This time it adds here. So see, 4 values, right? So that's what quadratic probing is. Now I'm pretty sure that now everything will be clear, right? Just one thing is that it is supporting your overall duplicates. We normally don't want to support that. Okay. In our case, it's checking here, then it will add hit here. So after 9 elements, basically, we don't want to support duplicates. In our case, we are implementing it just like our dictionary is. Okay. Great all. So let us now move forward and try to write the code for get as well. So we can quickly check it before we write for the read function. Okay. Great. So for the get, what we will do again is we will first get the initial index, right? How can I get that? Self dot hash function, and I can pass the key. So I will get the initial index where I believe it should be. So I say that, hey, your orange should be here. Okay. Let's say you added orange, it should be here. If it is not here, okay, so first I have to save this position. Current position equals initial index. Okay. Great. The reason I'm saving this position is to make sure that if I circle back down to this same position after writing the loop, then I should have some overall flag which tells me that, hey, you have reached the same position. That means it is not present. Because if I, let's say, ask you for pineapple here, then you will circle back to the whole array and still you're not going to find anything. Right, everyone? So that's the reason we are just doing it. Now we have to just make sure that we are running the same loop. So what is the loop? While self dot slots current position is not none. Okay. While this is not none, we will be keeping on increasing this. First case, if we found that self dot slots, okay, current position equals to key, then I can just return whatever is present in my values here. So I find that, hey, I found my key, right? Great. Current position, yeah, values, it's going to return. The reason I've taken it as not none here, okay, so I will explain this as well, that why this is not none. See, when you add via linear probing, it is for sure that if say I am adding orange here, okay, then either it will be here, either here, either here. I will not get none. If I get none, like it will not that it will skip some none here. Okay, the very similar thing if I explain you using that visualizer. So pay attention everyone. What will happen if we just refresh it? See, if I'm adding let's say 30, then I let's say add 58. It was 59, right? 59. And then I add 88. It will never be the case that it is going to jump something. So now if I want to find 88, pay attention. If I want to find 88, it will go here, then to the next one, then to the next one and get me that. If let's say I want to find some 89, okay, let us see that. It's going to come here. It's not fine and not fine. Here it should stop. So when it's found the none, it is going to stop because we are doing linear probing. So it is not that ever we are going to jump any particular position, right? So once this is done, self.values, then I'm going to find or change my current position to self.rehash and current position, right everyone? Then just one more condition is required. This will handle the case if we are not finding it, but if the full overall array is filled, then we will reach down to this initial index. If full is filled, then we should return none, or we can return not found, gone, full, or better language, traversed full array. Great. If we come outside of this, that means that we would have gotten a none. If that is the case, then also we should return not found. Okay, everyone. So I hope this is clear. Now let us quickly check this out. Let us create a h1 hash map, and I'm creating it just with 3. Okay, great. h1 dot insert apple and 10. h1 dot insert orange 20. Okay, let us just get h1 dot get apple. Let us make it same exactly because hash will be calculated, and let me print this. Print. Okay, see, I'm able to get 10. That means that my code for this particular hash map is running. Let us try to find banana and let us run this. So it's saying not found. The reason it is not saying traversed full because we found none before, right? So it would have happened. We will print it as well in the next video to see that how exactly they have been stored. Okay, but it would have found none before. That's why it is not basically saying that hey, I found a none, so it is giving not found.